Hey everybody. So let's try to solve this problem threesome. Given an integer nums, return all the triplets nums I, nums j and nums k such that I naught equals to j, I naught equals to k, j naught equals to k. Basically all these numbers are not equal. In this case, nums I, nums j and nums k should be equals to 0, the sum of these. The solution should also not have duplicate triplets. So let's take this example. In this list, these triplets sum to 0. So minus 1, 2 sum to 0, minus 1, 0, 1 sum to 0. In this example, it cannot sum to 0 at all. So we return an empty list. Over here, we can create one triplet. 0 plus 0 plus 0 is equals to 0. And we cannot create anything else. What if we had something like this? In that case, you might say that we can create this triplet and this triplet, but no, that is not allowed. We cannot have duplicate. Now, if you have previously solved the two-sum problem or the two-sum 2 problem, this would be a very straightforward problem. If you have not, let me give you a very quick look at that. So let's say we had a question like 2, 1, 3, 4. We had this as our list. And in a two-sum problem, we are asked to find two numbers, a plus b, which end up into a specific target. So for example, let's take a target of 5. The first thing we would do is fix the value of a. So a would become something like 2. Let's fix this number. So b, we are looking for 3. So we would like to find if 3 is present in this array or not, and we can see it is present. To make this search fast, we would over here use a map. We can further do that. So one of the solution we have is 2, 3, and then we would set the value of a to 1, which means we are looking for b equals to 4. Is 4 available in the array? And it is available. So that would be another solution, 1 comma 4. And to optimize again, we would use a map to search better. We use extra space in this. Now let's take a look at the two-sum 2 problem. In this, we are given a sorted list this time. And we are supposed to find very similarly a plus b equals to target. Let's say target is this time we are looking for 4. So over here, because this is sorted, we would use a property that we would point a left pointer here, we would point a right pointer here, and we can calibrate the sum by moving left and right pointer. Because we know it is sorted, if I move the left pointer to the right side, the sum of the values at left and the right would increase because we are going to a higher and higher value. If we move right to the left side, the sum would decrease because we are going to a smaller and smaller value. So if I want to find out 4 and a plus b over here is giving me 5, I'm getting a higher value. I want to reduce it. So to reduce it, I would move the right pointer to the left side to a smaller value. So right moves to over here. So now we have 1 plus 3, which is 4. So we got the answer. 1 comma 3 is one of the answer. So once we got the answer, we can still move further if we want to. So we move left to the next element and we move right to its next element. The left and the right are now on the exact same element. This cannot be valid because we are supposed to find out two elements. Since this is invalid, we can stop traversing and we have the solution 1 comma 3 gives us 4. So these are the two problems which can be used to solve this particular problem. Now let's take a look at this problem. Let's take this particular example. What we are being asked to find is a plus b plus c equals to 0. 0 over here is the target. And in a plus b plus c, we can divide this problem. We can say a plus b plus c equals to target, which means we are supposed to find b plus c equals to negative of a. So how about we take this problem, we sort this array first. So that would be minus 4. We are at minus 1. We are at minus 1, 0, 1, and 2. We sort this array. B is fixed to minus 4. And now we end up with a 2 sum 2 problem. In fact, we don't even have to use a map over here because a map was just searching the next element. And the next element we can search using the 2 sum 2 problem. So let's take a complete look at this solution. I have minus 4, minus 1, minus 1, 0, 1, and 2. This value would be A. And over here, I have B plus C. I'm trying to find this out, and this would be equals to minus A. So in this example, B plus C should be equals to 4. Let's keep a left pointer to this, a right pointer to this. This is left, this is right. The sum is equals to 1, which is not equals to 4. It is a smaller value. So I would move left. This left moves over here. And then I see that, okay, this value is the same as the previous value. So I don't want to move to the same value. Otherwise, it would make no difference. The sum would still be 1. So left, I don't want to move to a negative value. It's not just an extra computation. But just in case I found an answer, just in case this made sense, I would do a repetition of my solution, and we don't want triplets. So we would move to a unique element. So L would move to 0. Now we are at 0 plus 2. This has a sum of 2, which is not the same as 4. We are still very less. So let's increase again the sum. So L goes to 1. Now we are at 1 plus 2, which is 3 more, but still less than 4. Now L again moves to the next element. Now left became equal to right. This is invalid. We are supposed to find two elements, not one. So this would be invalid condition, and which means that our assumption of fixing A at negative 4 was incorrect, which means let's move A to the next unique element. Unique. If it was minus 4, we would not move it because that would result into the same solution. So let's not move to the same element. Let's move to the next unique element. So negative 1 over here. Let me clear this up. So now A is pointing over here, and B plus C is equals to negative A over here. So B plus C equals to that would be 1. So let's keep a left pointer here. Let's keep a right pointer here. The sum is 1 minus 1 and 2. The sum is 1, which is matching with 1, which means we have an answer. So let's take A, negative 1. Let's take the value at left, negative 1. Let's take the value of right, 2. This is one of the solution, and it matches with our output over here. Once we have found a solution, there might be more solutions. So in that case, we would move forward both the left and the right pointer. These both are moved. So now we have 0 and 1. We can see that the sum is coming up to be 1. So this is another solution. So minus 1, 0 and 1, 0 and 1. This is another solution. So this would be the basic algorithm of solving this problem. Let's take a look at the code implementation. So over here in the code editor, the function is accepting nums, which is the input over here. And we are supposed to return the triplets, which is a list of list. The first thing I would like to do is create a results variable. It's an empty list right now. Next, I would like to sort these numbers. So nums dot sort. In Python, you can do it like this. Next up, I would like to iterate through nums, and we would assign the value of A and B and C we will try to find out. So let's, for I in range length of nums, I would assign the value of A. A would be equals to nums of I. So if I draw the diagram for simplicity, I have something like this. So 1, 2, 3, and 4 and 5, we have a sorted list. So over here it's A, and over here we are trying to find out B plus C, and over here we would have the left pointer, and over here we would have the right pointer. Once we have our A assigned, let's try to create a target. So the target I am looking for is equals to negative A. Then I would like to have a left pointer which is pointing to I plus 1, and I would have a right pointer which would point to the end of the list, so length of nums minus 1. After that, once we are done with this, I want to iterate through the next part and I would like to find B plus C. So let's write this condition: while left is less than right, I want to keep iterating. Then I want to find the total. So total would be equals to nums at left and nums at right. Then let's check where is this total. If total is greater than target, I have a large value. I want to reduce that value. So when we want to reduce, we move the right pointer. Right minus equals to 1. Else if total is less than target, I would like to move left to the right to increase the value. Left plus equals to 1. If both of these conditions are not true, in that case total is equals to target, and in that case I would like to put it put this in the result. So result dot append, I have something like A nums of left and nums of right. This is in the result. Once we have the result, let's find next solution, which means move left to the right and move right to the left side. So left would move by 1 to the right side. It would increment. Now there is a possibility I'm looking at the same element. What if this was 2? I don't want to put left to the same element. I want the next unique element. For that, I can write a while condition here. If nums at left equals to nums at left minus 1, previous element, I would like to keep incrementing left until I find something where these values are not matching. Also, I need to take care of the bound. I might go out of bound. I might go on the right side of the right, and that would be an invalid condition. Over here we have written. So let me just say that left should always be equals to right. Now the similar rules apply to the right pointer, which would move to the left side. So over here, while nums of right is equals to nums of right plus 1, because we are moving it from the right to the left, it would be a right value comparing with right plus 1 value. And the similar bound would also apply over here. Left is less than right. After that, I would like to move right. So so the right would decrement. And also this is a typo. I should fix it to right minus 1. So we are done with this part. The one thing that we are missing is that this A does not move to unique elements as of yet. If this was 1 over here, the A would just blindly get assigned. We don't want that. We want to compare if we are moving to a unique A. So to do that, we can add a check over here. If nums at I is equals to nums at I minus 1, we don't want to do any execution. We just want to continue. But when I is equals to 0, we don't want to check with the previous element because there is no previous element. And this condition would actually be invalid. So let's just Add another condition if I is greater than 0. Only in that case I want to check with the previous element. I think we should be done with this. In the end, let's just return the result. Let's try to run this code. Let's try to submit it. So we have a solution. If you like this video, please consider subscribing for more such content.